All right, number 5 has a little bit of a twist to it, so bear with me here. First thing you always want to check is just direct substitution. So if we plug in infinity here, we have 1 plus infinity, which is infinity, and then to the power of 1 over infinity. And 1 over infinity, or 1 over x as x approaches infinity, is 0. So we have infinity to the 0 power. And at first glance, you may think that this just equals 1, because anything to the 0 power equals 1. However, infinity to the 0 is actually an indeterminate form. And on the last page of these notes, there's a list of indeterminate and determinate forms. And infinity to the 0 is just one of those things that is indeterminate. So we're going to have to do more. In order to use L'Hopital's rule, you have to have your indeterminate form in the form of either 0 over 0 or infinity over infinity. So there's something else that we're going to have to do here. And we're going to go back to the frowny face problems that we talked about earlier in the year, and that's when you have to take the natural log of both sides. What clues you in to the fact that you're going to have to take the natural log of both sides is this variable exponent, this exponent that's to the 1 over x power. So anytime your exponent is a variable, chances are you're going to have to take the natural log of both sides. However, we don't even have two sides of an equation here. This is just an expression. However, we can turn it into an equation by saying that this limit is going to equal some value. So if we say that the limit as x approaches infinity of 1 plus x to the 1 over x equals some number y, then I can take the natural log of both sides. So here I'm going to take the natural log of both sides. Now, the natural log of a limit is the same thing as the limit of the natural log of 1 plus x to the 1 over x power. And we learned that back in chapter 1. It's composition of limits. You can flip-flop the outer function and that limit right there. So if you want to, you can go back and review your notes from chapter 1. All right, and then this still equals the natural log of y. And the reason that we wanted to take the natural log of both sides is because now this exponent of 1 over x can come down in front. So it's the limit as x approaches infinity, 1 over x times the natural log of 1 plus x. I just used my properties of logarithms to bring that 1 over x down in front. And 1 over x times the natural log of 1 plus x is really the same thing as the natural log of 1 plus x divided by x. And the only reason that I'm writing this as a fraction is because I'm trying to get it into that indeterminate form of either 0 over 0 or infinity over infinity. And all the while, I need to keep in mind that this expression on the left-hand side still equals the natural log of y. All right, so now when I try direct substitution and I plug in the infinity for x, I get the natural log of 1 plus infinity. So it's the natural log of infinity over infinity. And if you will visualize the graph of the natural log of x, as x approaches infinity, the natural log of x is also going to equal infinity. So the natural log of infinity is infinity. So I get my indeterminate infinity over infinity here. So now I can use L'Hopital's rule. So I just literally take the derivative of the top of that fraction over the derivative of the bottom of that fraction. So the derivative of the natural log of 1 plus x, the way that you take the derivative of natural log is 1 over the argument times the derivative of that argument. Well, the derivative of 1 plus x is just 1. So that's the derivative of the numerator, and then the derivative of x is just 1. So if I clean that up, I've got the limit as x approaches infinity of 1 over 1 plus x. And this all still equals the natural log of y. So now I can take this limit. As x approaches infinity, 1 over 1 plus x is going to approach 0, because I effectively have 1 divided by infinity, or 1 divided by a number that's getting bigger and bigger and bigger and bigger. So 1 over a huge number is 0. So I have that 0 equals the natural log of y. Some people will stop there and say that the answer to this problem is 0. But the answer is not 0. 0 equals the natural log of y, and y is the actual answer to this problem. So I need to solve for y. Well, remember that natural log is log base e, so I can convert this to exponential form by saying e to the 0 power equals y. So e to the 0 power equals y. Therefore, y equals 1. So my answer is 1. And that's as hard as it's going to get, but you will at some point have to set your limit equal to y and then take the natural log of both sides in order to get your correct answer. All right, so the answer to that one is 1.
Limit as x approaches 2, is that from the left or right? Right. Of this right here. Now, L'Hopital's rule really kind of requires us to have a function divided by another function, and this is the difference of 2 fractions. So what could I do? Yeah, let's just combine them, and it already has a common denominator. So limit as x approaches 2 from the right is going to be 1 minus the square root of x minus 1 all over x squared minus 4. All right, plug in a 2, you get 0 over 0. So we can go to L'Hopital. What's the derivative of the top? Negative 1/2 x minus 1 to the negative 1/2, and then technically times 1 if you take the derivative of the parenthesis. And the derivative of the bottom is 2x. All right, let's keep our fingers crossed that this works. If I plug a 2 into the top, I get 1 to the negative 1/2 power. What is that? 1 over what? Yeah, 1 over 1. So just 1. So basically on top I have negative 1/2. And on the bottom I have 4. And negative 1/2 divided by 4 is negative 1/8. Okay, try number 7 on your own. Technically, this limit doesn't exist since it approaches infinity, but when a limit approaches infinity or negative infinity, I want you to designate the infinity or negative infinity.
All right, the last one on number 8. Don't forget that you always want to start with direct substitution. So if we use direct substitution here, the limit as x approaches 0 of e to the x over x, then when I plug in a 0 for x, I get e to the 0 power divided by 0. And e to the 0 is 1 divided by 0. So if my limit is 1 divided by 0, then that limit does not exist. Remember that a limit of a number divided by 0 does not exist. 0 divided by any number is just 0. And then we've talked about how 0 divided by 0 is indeterminate. And the only reason that I wanted to put this example in here is that when you've done L'Hopital's rule so often, then you could be tempted to just start by taking the derivative of the top and the bottom, without first checking to make sure it's in one of the indeterminate forms of 0 over 0 or infinity over infinity. So if you don't use direct substitution first and you jump into taking the derivative of the top and the bottom, well, the derivative of e to the x is e to the x, and then the derivative of the bottom is just 1. So now when you take the limit as x approaches 0, that would just equal e to the 0 or 1. And that is not the correct answer. So you can verify that on your calculator by finding the limit on your calculator using your table or using the limit feature on your home screen. But just always make sure that you use direct substitution first. Most of the time in this chapter, you're going to get either 0 over 0 or infinity over infinity and have to use L'Hopital's rule, but every once in a while they'll throw in a problem that you would have been able to do in chapter 1. So just be careful of that. So the answer to this problem is does not exist.
Some summaries and a little bit of extra information. Your indeterminate forms are all of the following right here. But you have to remember that the only two that allow you to use L'Hopital's rule are the first two. So if you get any of the other 5, you're going to have to manipulate that equation so that you can turn it into either 0 over 0 or infinity over infinity. Some of the determinant forms that you might get are infinity plus infinity is infinity, negative infinity minus infinity is negative infinity, infinity to the 0, or sorry, 0 to the infinity is 0. 0 to the negative infinity is infinity. So just remember that L'Hopital's rule can only be applied if you have 0 over 0 or infinity over infinity.